Okay, ladies and gentlemen, today we are going to talk about scatter plots, how to make them and how to interpret them. Okay, so at the very top, we're going to start here with our notes. A scatter plot is a graph that shows the relationship between two sets of data. To see the relationship more clearly, a line of best fit can be drawn. The line of best fit is drawn so that there are about the same number of points above the line and below the line. So for the most part, you just kind of have to estimate it the best that you can, but when you get into algebra next year, you'll learn how to actually find the perfect line of best fit. So there are three types of correlations or relationships that exist in a scatter plot. You can have a positive correlation in which the dots are generally going up and to the right, like this. A negative correlation where the dots are going down and to the right, or no correlation at all, which means the dots are spread all over the place and you really can't tell if they're moving up or down. Now, a positive correlation would be something like as one thing increases, something else increases. So, for example, if you're having a party and a bunch of friends are coming, the more people you invite, the more food you need to have. The less people you invite, the less food you need to have. That's actually a positive correlation. A negative correlation would be as one thing increases, the other thing decreases. For example, the larger the engine in a car, the less miles per gallon that car gets. And no correlation would be a situation where, let's talk about height and eye color. You don't have to be tall to have blue eyes. You don't have to be short to have brown eyes. There's no correlation between height and eye color. Okay, so the scatter plot below shows the number of CDs in millions. Make sure you read your graphs very carefully so you know what they're talking about, that were sold from 1999 to 2005. If the trend continued, about how many CDs were sold in 2006? Make your prediction. So the first thing that you want to do is extend the graph and draw a line of best fit. To make a prediction. Okay, so you're going to need a ruler in order to do that, and I like clear rulers on this because it helps me see the dots a little more evenly. So if I were to draw my line of best fit, I'm trying to see that I have about the same number of dots above and below. Again, it doesn't have to be perfect. It should be just a good idea. So I'm going to draw my line of best fit like that. And extending your graph just means carrying this out further. So if you notice, they're asking for you to predict in 2006, but this graph goes to 2005. So 2006 will be this line right here. So we're going to put a dot right about there. This would be where our prediction would be. Okay? And again, it's not always perfect, and I do leave some leeway for that. So if your prediction doesn't match mine exactly, then as long as you're somewhat close, we're good to go. So on this one, I would say, since this is 650, that's 7, so it's a little less than half, so maybe about 670 million would be my prediction on how many CDs would be expected to be sold in 2006. So that's, again, it's an estimate, it's not exact, okay? All right, so going down to the next one, again, we want to read our graph, make sure we understand exactly what the graph is talking about. If you notice on this one, we're looking at the weight and ages of beagles, puppies. Okay. So on the bottom are our ages in months. On the side is our weight in pounds. So what is the average age of the beagle when it's 2 months old? So we need to look at 2 months, and we need to look at the average weights right about here. So they seem to average anywhere from 8 to 10 pounds. So you could say the average was about 9 pounds, because that's in the middle of all of those. Because you can see this is about 8, that's 9, that's definitely 10 because it's on the line. Okay. And then at what age does a beagle typically reach 20 pounds? So we need to go up to the 20 pounds and come over here and I see a 20-pound right about there and right about here. So that's somewhere between like 3.5 to 4 months. So anywhere from 3.5 to 4 months is when a beagle typically reaches about 20 pounds. Okay. All right, so let's go ahead and flip over to the back. We're actually going to create some scatter plots on the back. So you will have to create, sometimes you have to create your number line, sometimes they will give you a number line. It all just depends. So the table below shows the predicted annual, which is yearly cost for a middle income family to raise a child from birth until adulthood. Draw a scatter plot and describe what relationship exists within the data. So if you notice, they've given us the cost here, but we don't have the age here. So I'm going to actually skip some lines, and I need to draw my X and my Y axis in here to make that stand out a little bit. Okay, so I'm going to give this my X axis here, my Y axis, excuse me. And then I'm going to create my X axis here, so they're nice and clear, just like that. And then I'm going to put my data in. Notice they're starting at about 3 months, so I'm going to start at 3. And then I'm actually going to skip every other line. 3, 6, 9, I'm sorry, years, not months, years. 12, and then 15, and then 18, and we'll carry this out to 21. All right, so we have our x-axis, we have our y-axis, we have our numbers. Now let's go ahead and plot the points. So at age 3, they're saying it's about $10,700 per year. So that's probably somewhere right around here. Okay. At age 6, it's about $11,700. So again, somewhere right around here. At age 9, it's about $12,600. At age 12, it's about $15,000, which is, oops, I went over too far. Sorry about that. $12,000. And at age 15, it's about $16,700, so somewhere right around there. Let me get rid of that one dot. That's my mistake. So we've got our data, and you can see where it keeps getting bigger and bigger and bigger, which makes sense because the older kids are, the more expensive they are. Okay, so we've got our data going in that direction. And now they said we want to draw the scatter plot and describe the relationship. Well, since the dots are going up in this direction, this is definitely a positive relationship. Okay. Okay. So we did our plot the coordinates, and we need to draw our line of best fit. So again, the best that you can on average. Probably somewhere right around here, give or take. Okay? And it doesn't have to go through the origin. Don't think it has to do that. It doesn't. You should have about the same number of dots above and below the line. Okay? And we did say a positive relationship. Then it wants us to do some predicting. So we want to predict the average cost of an 18-year-old and a 21-year-old. So 18 and 21. So at 18, we're going to follow this up until it reaches the line of best fit. And at 21, we're going to do the same thing, somewhere right around here. So at 18, that's a little bit above 18,000, so maybe about 18,200-ish. So somewhere around there. And at 21, it's right at about 20,000. And again, those numbers increase a lot, but if you think about it, those are college years. And if you're paying for your child's college, then that is part of the cost of raising that child. So that can also make a huge difference in the average there. Okay? All right, last one down here on the bottom. People can become very sick from bacteria found in contaminated food. Read the table and plot the points on the graph for the number of cases of botulism in the United States for the years 2001 to 2005. And again, we need to go ahead and fill in our X and our Y axis. That's first, because we don't have that. So I'm going to make my X axis, my Y axis here, and I'm going to make my X axis here. Okay, and then the year, this would be our X, this would be our Y. So our X is going to go along the bottom. That's the years. And I'm just going to do the last two numbers for the year. So we have the years here. Okay, I'm going to draw these little lines. And I know they kind of copied light. Sorry about that. Okay, so I'm going to have 01 here. I'm going to skip one, do 02, 03, 04, 05, 06, 07, and that should be good. Now, on the side, we're looking at number of cases of botulism. Notice that the lowest case is 16, the highest is 39. So I'm going to start at 0, and I'm going to go up by 4s. You can make your scale whatever you need it to be when you're doing a graph like this, but you try to fit your numbers in here as easily as you can. This one should incorporate all of the numbers that I need, and 36 and 40, and I'll even do 44 here. Okay? All right. So then we're going to plot these, and then we're going to draw our line of best fit and make a couple of predictions here. So in 2001, there were 39 cases, which means it's going to be right below the 40 here. In 2002, there were 28 cases, so 2002, 28 cases. In 2003, there were 20 cases. In 2004, there were 16. And in 2005, there were 18. So in general, we have a negative relationship. We do have a little bit of an upswing there at the end, but let's go ahead and draw our line of best fit. Oops, let me get a color here. So again, as you want to try to split the data as evenly as possible. Let's see. Somewhere right around there. Okay. Excuse me. Is there a relationship? Yes, there definitely is. And in general, it is a negative relationship, which is a good thing, because then that means people aren't getting sick from food that's not processed properly. And predict the number of cases in 2006. So we go over to 2006 and we put a dot right here for our prediction. And that is a little bit under the 8. So I'm saying maybe about 7 cases. So about 7 cases. Okay. Would be expected of botulism, which again, botulism is food that's contaminated because it's not processed properly or it's not pasteurized properly, and bacteria gets in there and makes people sick. So that is it for our notes. You do have homework. It is in your packet today, so make sure you get that done, and I will be back tomorrow to check everything. You guys have a great day, and I will see you tomorrow.